Hello students, in the last class, in the last video, I have explained about exercise number 1.2 in the real numbers. So before going to the exercise number 1.3, we have to concentrate on some things, that is rational numbers and their decimal expansion. You know that the numbers which are in the form of p by q are called rational numbers. The numbers which are in the form of p by q are called rational numbers. So here, for example, if you take 3 by 4, 3 by 4 is a rational number, and if you want to express as decimal, we have to divide it. We have to divide. We have to divide 3 with 4. So we get now here 3 we can't divide, so we take the point. So we get 30. 4 sevens are 28, and here we get remainder 2, and already we have taken point, that is 0. So 4 5s are 20. So here 3 by 4 is nothing but 0.75. This is called decimal expansion, or so rational numbers and their decimal expansion. So this is, now here I am expressing this rational number in the form of a decimal number. So here what you get, which type of decimals you get when you express a rational number in the form of decimal. So which type of decimals you'll get? You know that in the decimals we have several types: terminating and non-terminating, and non-terminating recurring, non-terminating non-recurring. But when you express a rational number in the form of decimal, we get either terminating or non-terminating recurring. So when you express a rational number in the form of decimal, you get terminating decimal and also non-terminating recurring decimal. We get only these two types. We don't get non-terminating, non-recurring. So why? Because non-terminating, non-recurring decimals cannot be expressed in the form of p by q. Okay. So here we get only these two cases. For example, now here you see 10 by 8. I'm taking 10 by 8. So I'm dividing with 10 with 8. We get point. You see here with 8 ones are 8. 2 is remainder. And I'm taking point. 8 to just 16. 4 is remainder. And I have taken already point. 8 5s are 40. So that is 1.25. But when you divide this 10 with 3, what do you get? So 3 3 is a 9. 1 is a remainder. So 3 3 is a 9. 1 is a remainder. 3 3 is a 9. 1 is a remainder. So now see, this continues like this. This is called non-terminating recurring. So now see, in this case we got a recurring, we got a terminating decimal. In this case we got a non-terminating recurring decimal. So recurring means repeating. Okay, so there is nothing but 3.3 bar. 3.3 bar. So in the case of division, yes, in the case of division, we get either terminating decimal or non-terminating recurring decimal. Okay, so but here, is it necessary to do always division to tell whether it is terminating or non-terminating? That's no need at all. Okay, so here just by observing this denominator, we can tell whether it is terminating or non-terminating decimal. Okay, so to understand that, we go for a theorem and we do some problems. So this is a theorem 1.3. So let x be a rational number whose decimal form terminates. So here decimal form terminates means we get, for example, you see 0.5, that is terminating decimal. 1.634, that is terminating decimal. Okay, so in this type of decimals, if you express in the form of p by q, yes, so if you write these decimals in the form of p by q, for example here 0.5 is there, so 5 by 10 we get. So 5 by 10, nothing but if you simplify, we get 1 by 2. Yes, so when you express in the form of p by q, The prime factoration of q is in the form of 2 power n and 5 power n, where n and m are non-negative integers. Means if the decimal is terminating decimal, and if you write them in the form of p by q, the denominator will be in the form of 2 power n and 5 power m. Okay, so here what do you mean being what is the meaning of that? We understand by using some examples. Let's see some examples here. So we have here do this. So here write the following terminating decimal in the form of p by q, where p comma q are co-primes. So these are all terminating decimal. This is terminating decimal. This is terminating decimal. This is terminating. This is also terminating. These all are terminating. Okay. So if you write this one in the form of p by q, first one is what? That is 15.265. So let us do that problem. So here first one, that is 15.265 I am taking. So this is terminating decimal. How to write in the form of p by q? Just you have to remove this decimal point. We get 15,265 by 1000. Here 3 decimal places are there. So if you get here 1000 in the denominator. If 2 decimal places are there, we get 100 in the denominator. If 4 decimal places are there, we get 10,000. Okay, now this one, if I simplify, what you get? Let us see. So here I am taking this, I am converting this into this denominator into 2 power n into 5 power m. Why? Because we always get 2 power n and 5 power m. So before that, we have to simplify this. Before converting, we have to simplify this both. Why? Because these both are ending with 5 and 0. So before converting, that should be expressed in the form of simplest ratio. Okay. So how can you divide this? How can you divide this? Now see, I'm taking once again 15,265 and 1000. So I'm dividing with 5. This both you can divide with 5. 5 3s are 15. Yes. And 2 we can't divide. I'm taking 0. 5 5s are 25. And 1 is remainder 15. 5 5s are 5 3s are 15. Again denominator 5 2s are 10. 5 0 zeros. So here still we can't divide this any other number. So we got 3053 by 200. Now this one denominator is 200, that we have to write in the form of 2 power n into 5 power m. So now see here 200 is there. I am doing prime factoration. 200s, 250s, 225s and 5 5s. Now we got 3053 by 2 square, 2 cube. 2 is 3 times, so 2 cube, and 5 is for 2 times 5 square. Now this is terminating decimal, and so when you write this denominator by using, when you express this denominator in the form of prime factoration, we got 2 power n into 5 power n. That is a rule we learned in the theorem. Yes. Okay. So here, if you see the theorem statement, now I repeat once again the theorem statement. X be a rational number whose decimal form terminates. Now this decimal form is terminating. Yes. Then the denominator, so the prime factoration of q is of the form 2 power n into 5 power m. Yes, we got it. Okay. So you can do in every problem this, do this, that will get the same thing. For example, let us see the second one also, and you can try the remaining. So second one is 0.1255. So now this one I am taking as in the form of p by q. So we get 1255 by, so we get 10,000. 4 zeros. 4 decimal places are there, we get 10,000. Now we divide with 5. 5 2s are 10, yes, 5 5s are 25, 5 1s are 5, and here 5 2000s. So we got 251 by 2000. Now let us take the denominator and we see what will be the form of prime factorization. 2000 is, so now I'm taking 210, 2000s, 2 500s, 2 250s, 2 125s, 5 25s, 5 5s. Now we got 251 divided by 2 to the power of 4 into 5 to the power of 3. That's all. Now see, the denominator is in the form of p power, and 2 power n and 5 power m. Yes, denominator is in the form of 2 power n into 5 power m. Okay, and one more important thing is, now here in the decimal form, here we got 4 decimal places. Yes, now you can observe that here the maximum power is 4 in the denominator. So if the maximum power is 4, then it will have 4 decimal places. Now if you see this first one, here 2 cube, we got 2 cube and 5 square. Here maximum power is 3. So here we got 3 decimal places. So like that. So here just by observing the denominator in the form of 2 power n and 5 power m, if n is maximum or m is maximum, that will contain the number of decimal places equal to number of n, and that is equal to value of n or m. For example, we got prime factorization, we got 7 by 2 power 4 into 2 power 4 into 5 square. Now in this, if you write this fraction in the form of decimal, we get 4 decimal places. We get 4 decimal places. So that is important thing you have to remember. And we can try. You can try the remaining all. You have 2 problems. You can try that easily. And you express the denominator in the form of prime factorization. We get 2 power n and 5 power m form. And the denominator is not in the form of 2 power n and 5 power m. Then we get a non-terminating recurring decimal. Yes. So here, and this one just now I told you. X is p by q be a rational number such that the prime factorization of q is the form 2 power n 5 power n. Then x has decimal expansion which terminates. That is like same like converse of the first before theorem. So 1.3. Okay. Now see here, just by observing, I told you. So here, just by observing, we can say whether it is terminating or non-terminating. Now if you see this 3 by 4, if you see the 4 in the denominator, so here this one, if you write in the form of prime factorization, we get only 2 square. Yes, so 2 square is nothing but 2 power n into 5 power m. Means here 2 square is nothing but 2 power 2 into 5 power 0. Okay, means this is the denominator is in the form of 2 power n into 5 power m. So this is terminating decimal. Okay, so here means we have how to do this problem. If the question is given, how to write the answer. Let us see here. Here, first of all, we have to take the fraction 3 by 4. Just you take the denominator and you write prime factorization, we get 3 by 2 square. So here denominator, you can write denominator is in the form of 2 power n into 5 power m. So it is terminating. It is terminating decimal. That's all. But before writing in the form of prime factorization, just you have to check that whether it is simplified ratio or not. Okay, for example, if you take this fifth one is there 80 by 100. You don't write directly 100 in the form of prime factorization. Okay, you don't do 100 prime factorization directly. Before that, there is scope for simplification. Now, since 0 is get cancelled, we get 2 4s are 8, 2 5s are 10. So we got 4 by 5. Now, if you see this denominator, we have only 5. So here the prime factorization is in the form of 2 power n into 5 power n, so it is terminating. So we get this is a terminating decimal. This all here also we get terminating, here we get terminating, here we get terminating. This is 14 by 5 square. Yes, and here this is simplified already and we got 4 by 5. So again the same statement you have to write here. Okay, so here denominator is in the form of 2 power n into 5 power n, so it is terminating decimal. And non-terminating, you know that non-terminating decimals. So write the following rational numbers in the form in the decimal form and find out the block of repeating digits in the quotient. So I'll explain one problem in this. Let us see the first one. The first one is what? 1 by 3 is there. Yes. So 1 by 3 we have to write in the form of decimal. Already you know that the denominator is not in the form of 2 power n into 5 power n. So it is non-terminating. We don't get terminating, means we don't get remainder 0. So we have to take 1 and we have to divide with 3. We take point, we get 0 here. 3 1s are 3 and the remainder is 3 3s are 9 and the remainder is 1. Yes, and again we take 0, 3 3s are 9, remainder is 1. So means you got here 0.333 so on. So there is nothing but 0.3 bar. So this is called what do you call that? Repeating digits. Okay, here only one repeating is there. So if you take this second one, 2 by 7, 2 by 7, I'm dividing 2 with 7. Let us see what is the quotient. Now take point, we get 0 here. 7 2s are 14 and 6 is the remainder, and here we take 0 again. 7 8s are 56 and 4 is there. 4 is the remainder, 40. 7 5s are 35. 7 5 and again 5 is the remainder. We take 0. 7 7s are 49 and 1 is the remainder. We get 10. 7 1s are 7. 3 is the remainder. Again we get 30. I'm taking here. 7 4s are 28. 2 is the remainder, 20. 7 2s are 14. 6 is the remainder, 0. 7 8s are 56. 4 is the remainder. 7 5s are 35. You can observe that we got already repeating part, means 285. Okay, so here 285714, 285714, that will continuous like that. So what is right answer? You have to write I'm writing here 2 by 7 equal to 0.28571 bar. You should not, if you are writing bar, you don't write again the repeating part. Yes, if you're not writing the bar, just you have to write these dots. Okay, so on. That will tells you that will continuous like that. Okay, so now here this is a non-terminating recurring decimal. Okay, non-terminating recurring decimal, and this one, if you consider this repeating part, here we have to consider two things. One is period and periodicity. Period and periodicity. Now if you observe this decimal, what is the period? Means the repeating part is called period. For here what is the repeating part? 285714. And periodicity means how many are repeating. Now here 6 are repeating, so periodicity is 6. And if you consider 0.46 bar, what is period? Period is 46. And what is periodicity? Periodicity is only 2. How many repeating? 2 are repeating, so periodicity is 2. So that is the expressing a non-terminating decimal in the form of expressing a rational number. This is a rational, okay, this is a rational number in the form of decimal. So in this case we are getting always non-terminating, non-recurring decimals. Just you have to consider that. Okay, now let's go for the next topic. Now see, if you see this theorem 1.5, x is a rational number such that the prime factorization of q is not of the form 2 power n and 5 power n. Then, so here just before I told you the denominator means in the consider the denominator. Then if you write in the form of prime factorization, then we get 2 power n 5 power n, then it is terminating decimal. But here if you're not getting that, then that is a non-terminating recurring decimal or repeating decimal. Okay, so that is the thing you have to consider. Okay, so and we go for the exercise now. So in the exercise I explain this concept. So now see the exercise 1.3. First one, how to do. So write the following rational numbers in their decimal form and also state whether they are terminating and which are non-terminating. Okay, now see here, I told you just before, you can divide and you can write it in the form of decimal. Yes, so write the following rational numbers in their decimal form and also state whether they are terminating or non-terminating. So here 3/8 is there, you have to divide it directly. I will explain the problem. All of you know the division. If some students don't know division, what to do? In 10th class, if they don't know division, what we can't do anything. So here I'm dividing 3 with 8, but only I can tell you one clue. So you're dividing with 8, you write the 8 table here. 8 1 is 8, 8 2 is 16, 8 3 is 24, 8 4 is 35, 2, 8 5 is 40. Yes, at 6 is 48, 8 7 is 56, and 64, 72. We don't take 8 10 is 80. Okay, so here point we take 0 is there. We got 30, it take the nearest 30 and less than 30, so that is 24. Add 3 is the 24, and here we got remainder 6. Again point is there, we get 0 here. 60, the nearest and less than 60, that is 56. 8 7 is the 56, and 4 is the remainder, and again we get 0 40. So 8 5 is the 40. So that's all. So if you write this or 8 table up to 9, so we get easily. Okay, so that is 3/8 is 0.375. Okay, and this is terminating decimal. What is it? Terminating decimal. So just you have to divide and you have to tell whether it is terminating or not. Okay, for example, if you see this third one, this one you can divide 229 with the 400, and you can write whether we can tell whether it is terminating or not terminating. And 4 1 by 5, 4 1 by 5, that is mixed fraction, so we have to write as improper. 5 into 4, first you have to multiply. 5 4 is a 20, and plus 20 plus 1, 21 by 5. Okay, so now we can divide 21 with 5, we get terminating decimal. 21 with 5, yes, 5 4 is a 20, and remainder 1, take 0, 5 2 is a 10. So that is 4.2. 4.2 is what? Terminating decimal. Terminating decimal. That's it. Okay. So and if you take this, if you divide 2 with 11, absolutely we get non-terminating recurring decimal. Okay. Sorry. 2 with 11. Point we take 0. 11 1 is 11. 9 is the remainder. 0. 11 8 is 88. 2 is the remainder. 0. 11 1 is 11. And 9 is the remainder. 0. 11 8 is 88. I think you got the repeating part. So that is 0.181818. Yes. So that is 2 by 11 is we got 0.18 bar. This is terminating or non-terminating? What it is? Non-terminating recurring decimal. Non-terminating recurring decimal. So like that, every problem you have to write, you have to divide, and you have to say whether it is terminating or not. Okay. And we go for second one. Let us see the question. What is question? So without performing division. Now here we should not do division. Yes, just before I told how to do division. But here in this case, you should not do division, and you have to say whether it is terminating or non-terminating. So according to theorem 1.4, and if the denominator is in the form of 2 power n and 5 power n, then it is terminating. Means you should write the denominator. You should write the denominator in the form of prime factorization. Then if you get that 2 power n into 5 power n, then it is terminating. And if you're not getting, it is non-terminating. Let us see the first one. And before writing in the form of prime factorization, before doing prime factorization, whether first of all you have to check whether it is in the simplest ratio or not. Okay, so let us take first problem. So that is 13 by 25. Yes, so here first one is 13 by 25, 13 by 3125. The denominator is 3125. So already that is simplified ratio. Why? Because we can't 13 is prime number here, but the denominator is not a prime. So here still we can't simplify that. So now I'm taking 3125 and writing prime factorization. So this number is ending with 5. So directly you can take 5. Before that you can check with 3 also. 3 plus 1 4, 4 plus 2 6, 6 plus 5 11. Sum of the digits is 11. So we can't divide with 3. So I'm taking directly 5. 5 6 are 30. And here 1 is remainder 12. 5 2s are 10. And 2 is the remainder 25. 5 5 are 25. So again we get 5 1s are 5. And of 12. 5 2s are 10. 5 5 are 25. And 5 2s are 10. 5 5 are 25. 5 5 are 25. So now we got 13 by 5 to the power of 5. So here, how to write the denominator? The denominator is in the form of 2 power n into 5 power m. So it is terminating decimal. Means that ratio represents a terminating decimal. Means if you divide 13 with 3125, to divide 13 with 3125, so the decimal whatever we get in the quotient that will end, and we get remainder 0. Yes, we get a terminating decimal. Okay, and next one, if you see this second one, 11 by 12 is there. So again the same thing you have to do. Okay, I will go for this fourth one. 15 by 1600. 15 by 1600 is there. So here this is not a simplified ratio. So before doing prime factorization for 1600, you have to simplify this. So you can that you can divide directly with 15. Can't divide 160 with 15. So I'm taking 5 table. 5 3s are 15. 5 3s are 15. And 10, 5 2s are 10. So we got 3 by 320. Now let us take 320 and do prime factorization. 320 denominator. So I'm taking first of all with two 160s, 280s, 240s, 220s, 210s, and 2 5s. So now we got 3 by 2 to the power of how much? 1, 2, 3, 4, 5, 6. 2 to the power of 6 and 5. Now again the same statement here we have to write. The same statement you should write here. The denominator is in the form of 2 power n into 5 power m. So it is terminating decimal. Okay, if you are not getting this form, means other than 2 and 5, if you are getting any other prime number, then it is not terminating. Yes, so that is non-terminating recurrent decimal. If you get any other decimal other than if you get any other primes other than 2 and 5, for example, if it is 29 by 343, 29 by 343, if you do prime factorization, that we can't do with divide with 2 3, 5, so we take direct 7. 7 4 is 28, 7 9 is 63, 7 7 is 49. So we got 7 cube. So here what should write? The denominator is not in the form of 2 power n into 5 power m. So it is non-terminating recurring decimal. That's you have to conclude. Okay. So every problem you have to do in this way. In this, and here you see that is already given. This is terminating. Why? Because the denominator is in the form of 2 power n into 5 power m. And also you can say number of decimal places if you write in the form of decimal. Here maximum number is 3. So we get after point we get 3 decimal places. Yes. And if you divide 23 with this number, we get a decimal number, and in that we have 3 decimal places. And if you see this second one, 7th one, here the denominator 2 square 5 4 7 7 4 5. Now here that is not in the form of 2 power n into 5 power m. That is not in the form 2 power n into 5 power m. So it is non-terminating recurring decimal. So you have to write fully the denominator is not in the form of 2 power n into 5 power m. So it is non-terminating recurring decimal. Okay. And if you see the next one, this all you can do easily. And so this one, before doing denominator prime factorization, you have to simplify that. 3 3s are 9, 3 5s are 15. Okay, directly you can write the denominator is in the form of 2 power n into 5 power m. So it is terminating. And here also you have to divide. 2 18s are 2 50s, 2 9s, 2 25s. So we get 9 by 25. Here we get 9 by 25 means already 5 square. Okay. So here the denominator is in the form of 2 power n into 5 power m. So it is terminating. And this also you can do. You can write in simplest form 7 table. 7 11s are 77. 7 30s means we get 11 by 30. Now again you have to write 30 in the form of prime factorization, means you have to do prime factorization for 30. We get 2 15s, 3 5s. So we get 11 by 2 into 3 into 5. So other than 2 and 5 we got 3 also. So it is non-terminating recurring decimal. So this is second bit is very clear to you, and we go for the third bit. Write the following rational numbers in decimal form using theorem 1.4. So here theorem we have to use. So that is very easy. Without division we can write in the form of decimal. Let us see the first one. (13 by 25 is the first one. Is 13 by 25. The question is we have to write the decimal form without division. Yes. So without division means now see, let's take 13 by 25. I'm taking prime factorization. We get 5 square. So here only one thing you have to do. When there is 2 into 5, we get 10. Yes, 110. If we have 2 square into 5 square, we get 100. So 2 square is 4. 4 into 2500. We have 2 cube into 5 cube. We get 1000. Means if the denominator is, for example, 5 by 100 is there, then we can write directly 0.05. Means if the denominator is in the form of powers of 10, that directly we can write decimal form. So here, for example, 61 by 1000 is there, 10,000 is there. Now here we can write how many places decimal here? 1 2 3 4. So here 1 2 3 4, 0.0061. Okay. So here only one thing we have to do. We have to convert this denominator into the form of 10 or 100 or 1000 or 10,000. Okay. So for that what to do? So here 13 is there, 5 square is there. 5 square is there. If you should have 2 square, then we get 100. So we write multiply with 2 square. So 13 into 2 square means that is 13 2s are 13 4s are 13 4s are 52 by 100. So answer is 0.52. That's all. Very simple. Okay. And if you take this one, let us see this one 23 by, you have to do the second one. Second one, after doing second one, you go for third. You think about the third one. 23 by 2 cube into 5 square is there. Here maximum power is 3. Okay. So here we get 23 by 2 cube 5 square is there. So here we should have equal pairs of 2 and 5. If 3 2s are there, we should have 3 5s. Means should we require 1 5. So I am multiplying the numerator denominator with 5. Yes, now you see 23 5s are 115 by, here we go, we have 2 cube and 5 cube. 2 cube 5 cube means that is what, 1000. So 115 by 1000. So we get 0.115. Okay, that's a simple thing. Okay, so you have to write the given numbers in the decimal form by using this concept. And if you see this 143 by 110, I'll explain this problem also. 143 by 110 is there. 110 I am doing prime factorization. 2 555s, 5 11s. Yes. So actually this 143 you can divide with 11. 11 1s are 11, 11 3 are 33. So we get 13 by 2 into 5. So 13 by 10. 13 by 10 means that is 1.3. Okay, that's all. So here 2 5 already equal pairs means here 1 2 is there, 1 5 is there. So no need of multiplying with any other number. Okay, I think you understood this. And let us see the fourth bit. That is express the following decimal numbers in the form of p by q. Write the prime factors of q. What do you observe? So here we have to express in the form of p by q. This already you have from 8th class onwards. Okay, so now I will explain these problems. Try to understand them. The first one I am taking first one. First one is 43.123. That is terminating decimal. Directly you can write in the form of p by q. 43.123 is given. Just you want to do only one thing. 43,123. I'm removing the point directly. So we get 1000. Here 3 decimal places are there. We get 1000. If you are able to simplify, you can simplify that. Yes, means here you can't. Your division is not possible. Simplification is not possible. For example, 1.52 is there. Get 152 by 100. This is another example. Okay, this way is here we can divide with 2 7s are 14 s and 2 6s are 12, 2 50s, again 2 3s are 6, 2 8s are 225. So now we got 38 by 25. That's all. If you are able to simplify that, you can simplify. Okay, now here these are all terminating. Very simply we can write. For example, 0.0006 is given. Here 6 by how many places are there here after point 1 2 3 4? We get 10,000. Still we can divide this 2 3s are 2 5s to 5,000. 3 by 5,000. So this type of problems easily you can write in the form of p by q. Okay, and if you take this one 0.1201120 is here, actually this is non-terminating, non-recurring. Non-terminating, non-recurring decimal. So it cannot be written in the form of P by Q. Mean that is a irrational number. Yes. So that is irrational number. So we can't express in the form of P by Q. Okay. And these are another model that is non-terminating repeating decimals. This we can write in the form of P by Q. So I think you understood that after point of decimal point, if the repeating part is there or terminating part is there, then that we can write in the form of P by Q. But these we cannot write in the form of P by Q. Okay. So let us see the third one, and I explain some more models, some more problem also. So here, let's take the third one. So here, first one, we have to take the decimal number, 43.12 bar. You have to write in the form of P by Q. First of all, let us assume that as x, let x equal to 43.12, so on. So here, this is repeating decimal, non-terminating recurring or non-terminating repeating decimal. So here, this one, let us take equation number 1. Yes, this is equation number 1. So here, what you do? You have to observe the repeating part here. 43.12 is there. How many? What is the period 1, 2, and what is periodicity? Two are repeating. So only one thing here. So we when you're subtracting, you should have the same part after the decimal. For example, now see, we have to multiply this number with 100. Okay, if periodicity is 2, means how many repeating? 2 are repeating. So periodicity is 2. So we multiply with 100 on both sides. 100x equal to. So when you multiply with 100, the point moves 2 places. Okay. In any decimal, for example, if you multiplying 10 with 4.3, point moves to here, means we get 43. If you are multiplying 1000 with 1.67842, then point moves 3 places, means we get 1678.42 like that. Okay, so that thing you have to remember. So here, what is given there? 43.121212 is there. So I'm multiplying with 100. Okay, so we get 4312.121212. So why I am multiplying with 1 to why I am multiplying with 100? That is to get a repeating part again after decimal. If you multiply with 10, if you multiply with 10, we get only 431.21221. So the same part we going to get. For example, the same question, I'm taking one more example. The question is this one, 23.765 bar. Okay, in that case we take let x equal to 23.765. This one we take equation 1. Now multiply with 1000, we get 1000x equal to, point moves 3 places, 765. So here, this one is second equation. I think you understood here. In the repeating part, if we have 3 decimal places, we multiply with 1000. In the repeating part, you have 2 decimal number, that is 2 digits, we multiply with 100. Now we subtract these both, equation 2 minus equation 1, we get 100x equal to 43.121212, and this is x equal to equation number 1. I've written here wrong, sorry. The second equation is 4312.121212, and first equation is x equal to 43.121212. And you just subtract them. We get here on the right side we get all zeros after decimal, and here we get 12 minus 3 is 9, and 10 minus 4 is 6, 2, 4. So we get here minus 1, 99x. 100x minus 1x is 99x. So x equal to 4269 by 99. So that is what you have taken x, that is 43.12 bar equal to 4269 by 99. That is the answer. Okay, and if you do this, if you continue this, we have to subtract equation number 2, equation number 1 from equation number 2. So again we take here 1000x equal to 23765.765 so on, and x equal to 23.765765, and we subtract them. Subtract what you get, so we get 999x. 1000x minus 1x, that is 999x equal to, and after decimal point we got all zeros. Here 5 minus 3 2, 6 minus 2 4, 7 3 2. So we get x equal to 2376742 by 999. Okay, so this is the process. This is the process of writing in the form of P by Q. Okay, here we have only given terminating decimals only, non-terminating and pure recurring. Non-terminating, pure recurring decimals only. So we do one more model also. I'll explain one more model. The question is this one. We have question this one, 2.354 bar, 57 bar. Here bar is only on 57, means the repeating part is only 57. Okay, this is called mixed recurring decimal. First of all we take that as x. Let x equal to 2.3575757. Okay, so in this case we have to multiply it with 2 times. So first time the point must move to this non-repeating part, means up to here. Okay, so I'm writing here arrow mark, and again one pair of repeating part, means here up to 57. So here we have to multiply with 10, again we have to multiply with 1000. So 2 times we have to multiply. So multiply with 1000 first. 1000x equal to, we get 2357.575757. Multiply with 10, we get 10x equal to 23.575757. We have to subtract them. So we get 990x. 1000 minus 10 is 990x equal to, after point we have all zeros. Why? Because all 57s are there. 7 minus 3 is 4, 5 2, 5 minus 2 3, 3 and 2. So we get answer 2334 by 990. If you are able to simplify that, you can simplify that. 2.357 bar is nothing but 2334 by 990. This you can divide with 2. 2 1s are 2, 2 1s are 2, 2 6 are 12, 2 7 are 14, 2 4s are 8, 2 9s are 18, 2 5s are 10. So we get 1167 by 495. Okay, so I think you understood this. Here, for example, the decimal number is 11.2346. Bar is on 346. So what do you get now? 11.2346, 346, 346. 346, 346. 3, 4, 6. In this case, what do you think? We have to multiply 2 times. The point must move to here, means before after the non-repeating part, and also one pair of repeating part, means up to here. Means we have to multiply with 10. Here how many places? 1, 2, 3, 4. We have to multiply with 1000. 10,000. So once we have to multiply with 10,000, and one more time we have to multiply with 10. Okay. So here there is a process. Thank you.